going to walk you through the example we did today in class just to make sure you understand how the implicit differentiation process works. So the first thing you're going to do is you're going to replace any dependent variables with function notation. You know which one the dependent variable is because it's on the top of the Leibniz notation for the derivative. The bottom is the independent. So everywhere I see a y in this, I'm going to replace it with an f of x. So I have x squared plus 3 times x times f of x plus 2 times f of x squared minus 6x plus 4 times f of x equals negative 5. And then I'm going to take the derivative using appropriate rules. I'm going to take the derivative with respect to x, because that's my independent variable. This first thing, derivative of x squared, is just going to be 2x times the derivative of x with respect to x, which would be 1, plus, and then for this, because I have a multiplication going on, 3x and f of x, I have to use the product rule. So that would be first, which is 3x, times the derivative of f of x, which is f prime of x, plus second, which is f of x, times the derivative of 3x with respect to x, which is 3. And then, for this thing, I'd have to use the chain rule, where the outside function is 2x squared and the inside function is f of x. So if I took the derivative of that, it would come out, and I'm not going to show all this work, but it would come out as 4 times f of x to the first times f prime of x. The derivative of negative 6x is negative 6. The derivative of 4 times f of x is 4f prime, because that's the constant multiple rule. And the derivative of negative 5 is 0. So now I want to isolate f prime of x. So I'm going to take every term that has f prime of x in it and leave it on one side and move everything that doesn't over to the other. So 2x, no f prime, so I'm going to move it over. 3x times f prime of x has it, so I'm going to leave it. 3 times f of x does not, so I'm going to move it over. 4 times f of x times f prime has it, so I'm going to leave it. Negative 6 doesn't, so I'm going to move it over. And this last term has it. So when I move this stuff over, it'll look like this. 3x times f prime of x plus 4 f of x times f prime of x plus 4 f prime of x equals negative 2x minus 3 f of x plus 6. And then, to isolate the f prime, it's a common factor now in everything on the left-hand side. So I'm going to pull it out. That'll leave me with 3x plus 4 f of x plus 4. And then I'm going to divide both sides by what f prime of x is being multiplied by. Oops. My eraser, there it is. So that would be negative 2x minus 3f of x minus 6 all over 3x plus 4f of x plus 4. And I'm going to switch this Leibniz notation now, which should be dy dx equals negative 2x minus 3y minus 6 all over 3x plus 4y plus 4. So if I wanted to find the slope at a particular point, like 1, 0, for example, I would plug in 1 for all the x's and 0 for all the y's. And that would give me negative 2 minus 6, which is negative 8, over 3 plus 4, which is 7, and that would be the slope of a line tangent to this graph at the point 1, 0.